the concept of variational autoencoders or VAEs. Variational autoencoders are generative models in which an encoder learns to map input data to a low dimensional latent space, and a decoder reconstructs the input data from the latent representation. To understand this, let's understand how an autoencoder functions. Imagine a photographer taking a high resolution photo of a location and then making a low resolution thumbnail of that photo to comprehend this better. The thumbnail may not have as much detail as the original photo, but it still provides an excellent depiction of the situation. Similarly, autoencoders compress a high dimensional dataset into a lower dimensional representation. Now, VAEs take the concept of autoencoders a step further. In addition to learning how to compress data, they also learn how to generate new samples that are similar to the training data. This means they can create variations or newer versions of the input data. In VAs, the encoder translates the input data to a lower dimensional representation, while the decoder converts the lower dimensional representation back to the original input space. This is a pictorial representation of a VAE. Now, let's see what VAEs are used for. VAEs provide a framework for learning meaningful and continuous latent representations, allowing for controlled and structured generation in generative AI. This means they are primarily used for generative tasks such as generating new data that is similar to existing data. So that is all about VAEs.